Okay, please let the people in. So the stream is ready.
Okay, welcome everybody. Welcome all the participants and panelists. It is for me a great pleasure to moderately hope the panel of today of a wonderful topic, because if we look a little bit into the future, the technology outlook 2021 was not only just a report of the Swiss Academy of Technical Sciences, but it was much more. It was really looking into the future and trying with this really to see what is relevant for our society on the technology side for our societal development. It's my big pleasure that we can have a Science at Noon around this very important topic for all of us. It's also wonderful that we can have a group of panelists that will really introduce the topic, but also stimulate you for possible further questions, and questions that will even not only close at 2 o'clock today or 2:15, but actually you will carry on and will remain in exchange with us, as we often do with this Science at Noon, that it initiates a process of discussion, a process of thinking, a stimulating process. It's my really great pleasure to welcome the different panelists, and I would like to start with Claudia Scherer. She was a key figure in the Swiss Academy of Technical Sciences, and with this technology outlook, she will present the short summary of this report as an entry into the discussion. We have then on the panel also Alessandra Hall. She is actually coming from the field of rare elements, as well as actually from the ESM Foundation, and actually is really going on this very important topic of this how can we recycle something that is very rare. We have also Greta Patzke, Professor Greta Patzke. She is actually bringing us into the field of the artificial photosynthesis. I mean, a broad topic in the energy field in our life, and I think she is from the University of Zurich and will make a few injections, not covering the whole topic, but really move a little bit the field on the most promising avenues that we have to pursue. It's wonderful also to have, actually in a sort of a double function, Professor Anna Valente from the SUPSI in Ticino. I always try to say Università della Svizzera Italiana, but that's not entirely correct, because it's the Fachhochschule. But this doesn't matter. We are all together, and we are all together in the same boat. And Anna Valente is not only a representative of the Swiss Science Council, but actually is also very much, as those who have seen the report, very much involved in the field of robotics, automation, and related areas. And from there, we also jump then to Max Erik Busse, who is from Maxon International, And here we are also in the field of robotics and automation. And as you will see, a very promising field that we need to explore together. And finally, a little bit going back to the life science, we go to Professor Daniel Gigax, and he is actually on point of care diagnostics, a very important issue in new technologies, that you are not let the patient come, but actually that you are really trying to serve where he or she needs to be served. And he is from the School of Life Sciences of here in northwestern Switzerland. So I would like to welcome you all. I think we will have an exciting short hour. And as a first step, I would like to ask now, as I said, Claudia Scherer to make a few injections into the discussions with a condensed summary of the summary. Thank you very much, Claudia Scherer.
So thank you, Master Tanner, for the kind introduction. As mentioned, today's discussion puts our technology outlook really on the spot. The panel focuses on stars and hopefuls, somewhat catchy expressions that transmit certain expectations. But what do the expressions actually signify? In order to answer this question, I need to travel back in time and explain very briefly the making of the technology outlook. It is the product of our early identification process and appears every second year. It detects, describes, and assesses disruptive technologies that will be of significance for Swiss economy and society in the coming years. The current edition includes 45 technologies and 13 what we call technology trends. So let's see. Okay. Okay. Can you still see the screen? Okay, quantitative data is collected on the different technologies to position them in a 4-quadrant diagram, which shows on one hand the economic significance of the technologies for Switzerland, and on the other hand the research competence in Switzerland. In our opinion, there are 4 major elements as to the economic significance of a technology: the worldwide revenue generated by companies based in Switzerland, the market potential in the coming years, the legal and regulatory framework, as well as the impact of society. In the publication, those 4 variables are combined into total value, whereby they are weighted differently. The revenue is the dominant building block, while the other variables act as mere modulators. 4 relevant building blocks are used to calculate the research competence: the number of Swiss academic research groups active in the field, their competence in international comparison, the number of companies in Switzerland active on this topic, and again, the competence of these companies in an international environment. As before, the 4 variables are added up to total value. So how can these elements be combined to generate a meaningful representation? If the economic significance is considered as the horizontal axis and the competence as the vertical axis, a square representation is created. And this is also where the connection to the topic of today's panel is made. Technologies with high revenue and high research competence are found in the upper right quadrant and are considered stars. On the other hand, technologies with yet low revenue and yet rather low research competence are placed in the lower left quadrant and are called hopefuls. When populating this square representation with the technologies of today's discussion, there is 1 star, point of care diagnostic, whose significance has increased over the past year. Collaborative robots, recycling of rare elements, and artificial photosynthesis are categorized as hopefuls. For them, the economic significance and research competence are still estimated to be low, and the development is rather unclear. So that was the very brief summary of the summary.
Thank you very much. Most welcome. This is very helpful, and I think this sets the scene for all of us, and we are very happy that we have now this injection, and you didn't have to read the whole report, but we actually would like to start now with the panel discussion. In the first,
sorry, Marcel, we can't see you.
yeah, it's sorry, Marcel. It's this new setup. I'm very sorry for that. I hope. Yeah, I would like to say that we would like now to start the discussion after this injection, and I would like to ask in a first round each of the panel participants to make a short introductory statement, a little bit on their technology and how they pursue it. And if you want to add something to your CV, of course, you are free to do that, but not more than 3 minutes. I would like to invite now first Professor Greta Patzke to maybe start with her round. There's no specific round. I mean, if so, but Greta, if you could start, would be wonderful.
Thank you very much for that kind introduction and the honor to open. I'll try to keep it short and sweet. So I'm proud today to speak for the University of Zurich, our research group, and also most importantly, the university's research priority program on solar light to chemical energy conversion, which is another name for artificial photosynthesis. So in our consortium in the University of Zurich and in our group, we focus on one single chemical reaction that is a big hopeful. This is the splitting of water. And if you split water, you can generate oxygen, of course, and also hydrogen as an energy carrier and energy vector. So how do we do this? I mean, I want to set this straight that there are many research groups all over the world who focus on that kind of research. And we have made our way in the past years in our group towards a good standing in that field, also to strengthen the Swiss research scene. And the point is, in water splitting, it's such a simple reaction. You just split water and get your hydrogen, but there are many, many obstacles. It is very demanding energetically, and also you need to overcome very sluggish kinetics. And to that end, you need catalysts. And this is what we focus on. In our group, we focus on the hard part of the water splitting. That's not the hydrogen making that we can use for energy carriers, but the oxygen making. And to that end, we look at nature. Natural water splitting as a natural photosynthesis is based on molecules. So in the group, we focus first on molecules, try to understand how they work, look at them, construct them, and then we aim to translate such knowledge into catalysts that hold up for many years and technical applications. And the technical part that's most prominent today is electrolysis of water. Probably you all know this. You put 2 electrodes and current, and then you do that rather brutally by electrolyzing the water. But to that end, you need very good catalytic materials. In our group, we have found such catalysts. They are vital to increase the longevity of these electrolyzers, to increase their efficiency. And we look at those materials as nanomaterials, for example, and look at their behavior while they help us to split water to generate hydrogen. And this is the insight that we need to make the materials better, to make them cheaper, to make them with locally available elements, to make them environmentally friendly, good for recycling and the likes. And this insight on the atomistic molecular level, that's the point of research. And later on in the panel, I would be very happy to outline the meaning of this for Swiss energy landscapes and research. Hydrogen has an enormous potential to drive heavy transportation, to cover our energy storage needs, winter storage, just to speak of this. But I think the excitement in research is also to look into these catalysts that drive the hydrogen and oxygen making and see basically on the atomistic level how they work and to translate this into how they work better. So this is basically what we do in a nutshell of 3 minutes. Thank you.
Thank you very much. That was very clear and a clear way forward. Splitting water in a way, and with all very common molecules, and we are therefore changing, but we don't discuss that now. This was the introduction to set the scene. We immediately change over to Alessandra Hall, because there we are not with common issues, but we are actually with rare issues. And I think you would, from the common to the rare, make a good bridge. Please, Alessandra.
Thank you. Yeah, rare earths and in general critical raw materials are not as rare as the name might suggest. They are, of course, limited resources, as so many are. But we find them, we're actually in touch with them every day. So people are in touch with rare metals when they use their mobile phone or when they use their laptops. And they are more and more needed for low carbon futures, such as photovoltaics, electric mobility, and so on. And this is what makes them so important. My foundation is dedicated on critical raw materials. And the topic is already a little older. So already in the 1950s, people were aware that there are certain technology metals which face certain risks of not being available, but it has become more and more timely exactly because of the need for crucial technologies, as I just have mentioned. What we do is that we work with a lot of different stakeholders from Switzerland, but also from Europe and internationally, on critical raw materials and a more sustainable management of them. It is really important for these materials, which will continue to decrease in demand, to have a secure and sustainable supply of them. And Switzerland, as an example, we don't have any own mining activities on these metals. So it is important that we look how we secure the supply base, and also how to reduce the impact that can be severe in mining and processing. And this is one of the reasons why it's really important to have a more circular economy of these metals. And this is not only a technological question in the sense of what are the recycling technologies, but it's also a question of how do we design the economy in a way that makes it viable to have a circular use of these materials. So what we try is to make people, and especially also politicians and companies, aware of the need to think about more circular systems.
Wonderful. Thank you very much, Alessandra. That was also very clear and to the point. Another important field, and it's very interesting that you mentioned that this is not a new story, the rare earths and all the thinking around it. And in your particular case, and our particular Swiss case, also the recycling part. I would like to move on to Daniel Gigax. Actually, before we go to robots, we go to people, and therefore point of care diagnostics and all the areas are quite relevant. Yeah. So Daniel, could you please bring in your life science perspective here on the new technologies, please?
Okay, thank you, Marcel. My research interest is the biospecific interaction. These interactions are a universal principle in cells, tissues, and whole organisms, where they process information and orchestrate actions. So we use these interactions as a tool to develop analytical test systems, such as enzyme or also immunoassays. And one representative format is actually lateral flow immunoassays, which are simple and provide rapid and reliable results when properly developed. And the results can be evaluated with a portable reader. For example, data can be transferred to PCs and specific apps on websites. So these characteristics will make testing more mobile and digital in the future. And as a consequence, some of the testing can be moved from the central laboratory to the point of need. So this approach can be implemented in a wide range of areas, such as medical care, veterinary medicine, food analysis, and environmental monitoring.
Thank you. Thank you very much. No, this is wonderful. And I think I hope everybody has realized the scope and the breadth that you can, from the technological thinking and principle, really apply for the benefit of, in this case, of societies and particularly also patients in the way. And thank you very much. And now we move a little bit to robotics after we're talking about populations. So we talk about the population of robotics, automation, and so on. And I would like to ask Max Erik Busse to make a short injection for the discussion, please.
You are on mute.
Yes.
I'm responsible here for technology transfer at Maxon. And so I want to give a little bit of an insight of what we are also looking at in our technology, our outlook internally. And so robotics is clearly one of the themes which is pervasive everywhere, which comes with a big promise, but also with a big threat. The big promise is that robots are really collaborating with us, and the big threat is that people are afraid actually of losing their work because of robots. And I think both of them are not even half true. So to begin with, robots at the moment, collaborative robots are still in the hopeful stage. They are not really driving business. And the reason is that collaborative robots are at the moment far too slow and far too clumsy to really collaborate with humans. So if you want to really have close human-to-human collaboration, these would be just too slow. So we restrict normally robots to 4D, 4D being dull, dirty, dangerous, or disallowed activities. So dull would be something like, for example, loading and unloading machines. Yeah, that's very dull. Dirty, dangerous, that would be like soldering or handling chemical substances. And disallowed would be something like handling explosives or radioactive material. These are really the fields where the low-hanging fruit is for cobots. As for destroying workplace, I would say if cobots really can help you get up with productivity, Switzerland is an open economy. And normally for every workplace that you cancel, you would normally get two. So we have a still very positive correlation between higher productivity and more workforce here inside Switzerland. So I would say that that's not a threat at the moment. Yeah.
Thank you very much. That is really also to the point, Max Erik. Thank you very much. And I would like to hand over now to Anna Valente, who actually carries somehow two hats. And the one hat is the Swiss Science Council, and the other hat is, of course, being actively involved also in the field of automation, in the field of robotics, where she is really, as a scientist, very much involved. So, Anna, would you please start first with your science and your technologies, and then you could just go on by rounding up this first round by having a view how the Swiss Science Council views these new technologies, and if these new technologies are somehow on the radar of the Swiss Science Council, and how. But let's first start with what is dear to you, your science, please.
Sure, thank you so much, Marcel. Well, of course, my role is to be a professor of industrial robotics. I do chair the laboratory for automation, robots, and machine with SUPSI. And in here, what we do is basically a twofold activity. So we do design, engineer, and prototype advanced solution of robots that are primarily conceived for industrial application and for indoor and outdoor. And we do also design, engineer, and prototype accurate machines, primarily laser-based machines, such as machines for additive manufacturing. And this is actually the technology that is the subject of my contribution for the Technology Outlook 2021. As you can imagine, laser and in general photonics is a very key branch for Switzerland and actually worldwide. This is a big market. We are talking about pretty much 500, almost 600 billion in 2020, and it's growing very fast at 7%. And in Switzerland is actually one of the key segment in terms of industrial value chain. It employs 9,000 highly qualified personnel, and is the second highest per capita in Europe. Of course, additive manufacturing plays a central role in photonics and in manufacturing value chain in general. It currently values something like 15 billion and is growing at a pace of 21%. So very fast growth. And our contribution primarily targets robots, devices, and machines that could enable somehow cutting-edge laser manufacturing application. For instance, if you, I would be supposed to give you a few examples about additive. What is very interesting right now for us is in the field of metal processing, we are kind of heavily working on functionally graded applications. This means to blow out metal particles, metal powders from nozzles, where we can change the alloy chemistry while we are ejecting the material. And this means to change the mechanical properties of parts across the topology of a single component. Then we are working also, and this is a very interesting field in Switzerland in general, to integrate multiple laser-based technology in a single piece of equipment. And one last aspect, concern the process control, where we can integrate sensing infrastructure and make available this technology to also early beginners. So the photonics in general, it's something that in Switzerland is boosting, and is definitely an instrumental and very interesting field for the Swiss economy and the industrial value chain in general. Now, when it gets to the Swiss Science Council role with regard to the technology, what is very important, first of all, to understand is that the goal of the Swiss Science Council, in conformity with its role as an independent consultative body, is to promote the framework for a successful development of the area system in the long term. This is very important to us. The council right now, the council board, is actually quite heterogeneous in terms of competencies and experiences, and this provides actually the opportunity to appreciate multiple technology, to observe the area system from a comprehensive perspective, and not just in terms of topics of specific subject, but in terms of new scientific challenges, as well as in terms of effectiveness in translating cutting-edge technology in solution and services that would bring actually tangible benefits to society. Now, the link between the Swiss Science Council and technology is not entirely direct, though, because the Swiss Science Council has been contributed to technology development indirectly by evaluating all the research organizations which are partly financed by the government through the Article 15. So from XAM, for instance, to Hyperloop. So our role is not to select or prioritize technology per se, but to work on the approach. So to work on the framework, to work on the policies in innovation. So here we assess the strategy towards excellence at national and international scales, the robustness as well as efficiency of the network between the various stakeholders at national scale in the short, mid, and long term, and the outcomes in terms of benefits for companies, so all the industrial stakeholders, the private ones, the public ones, society, and environment. Of course, mastering and being leaders, I would say, in specific technology is one of the key to target the aforementioned goals. So for us, excellence, so the way to support excellence, the pipeline to achieve excellence is actually the key, the core interest.
Thank you very much. That was also very clear with the two hats You actually already gave a perspective also on the Swiss Science Council, and that's actually something that we will deepen. But before we do this, I would like now, after these introductions, and that has surely all our listeners and followers of this roundtable fascinated. The question is anyhow, when you look a little bit in the future, could you be, for your technologies, a little bit more precise where you would see a good position, not a niche position, but where they would play an important role for the future with very practical examples? That would be wonderful. And I would again begin with Greta Patzke, who would actually be more concrete in splitting the water and where actually are the most promising avenue. Greta, please.
Yeah, thank you. Should I keep it to 3 minutes again, right? Or so?
Whatever. I mean,
okay.
Now it was only the introduction round. It's the 3 minutes. Now
Good.
You can have a bit time, but I think you should not have the whole time up to 2 o'clock, please. Yeah.
Sure.
Otherwise, its time is proceeding already. Yeah. Just short. Yeah.
So, yep. Thank you very much. So I would like to make the case for hydrogen in Switzerland first, and then go down to the specific research challenges. So I think generally we all agree that we have the energy strategy 2050, and a good chunk of this new energy must come from Swiss renewables. And we are talking also about hydrogen here, because it's clear to us that we have no decarbonization without decarbonized molecules. We cannot leave it all to electricity in our energy future. We must also have molecules at hand. And the turnkey to a new economy that's clean and green is basically hydrogen. And this is why we work on the artificial photosynthesis. Of course, there are other parts of such green molecules, carbon capture, storage, and utility, and these things. But today it's going to be from my side about the hydrogen. So, but we are very well aware that you can do related things with CO2 to get your foot into the door to totally decarbonize production and commodities. No electricity only society, but how to get the hydrogen. And I think for Switzerland in particular, we have to be aware that the hydrogen market, the low carbon hydrogen market in 2030 worldwide is esteemed to raise to $25 billion US. So we really have to get a piece of that cake, so to speak. And we have a very, very interesting point of application in Switzerland for hydrogen that's already being pursued with H2 Energy and other companies. So that's called a network called HydroSpider. And this is fascinating. Basically, there's a plant running in Gösgen where hydropower is used to make 300 tons of hydrogen per year. And that would be, to give you a perspective, serving 1,700 cars alone or 40 to 50 trucks. And this is the immediate business point that's in action already in Switzerland. If I may name companies, as we agreed on, the company Hyundai is now delivering heavy-duty commercial trucks to Switzerland to transport our goods. And we know how important that is when looking at the UK situation, for example. Trucking is vital. And there are trucks in operation solely driven with hydrogen fuel cells. And there are also filling stations for hydrogen in action from Lake Constance to Lake Geneva. So that's fascinating. And more is in the pipeline, literally. More trucks are going to be delivered and more filling stations are being built. And there is also talk from other companies about a second plant of that kind. And in the long run, we have the potential here to make a second pillar next to electrical cars that are also, in terms of recycling, thinking about batteries, pretty challenging, or could become so. And hydrogen transportation, especially for heavy duty, is a great thing. And this is in the making. I really wanted to alert you of these facts. You can read that conveniently online. But now where's the point of research? The point of research, now we go to the more specialized level, is also in the efficiency. If we talk about water electrolysis, from clean electricity, that's a two-step process. So we have to first make green electricity. Otherwise, the hydrogen, as they say in the field, is not green, but not so clean, maybe even gray. This terminology is very funny, but we have to have green electricity coming from solar power or hydropower or wind power, plus the electrolyzer step. Now, this is, if you do the simple math, efficiency times efficiency. If we count 70% for electrolyzers and an optimistic 28% for concentrated solar power, for example, you still wind up with a modest overall efficiency. And I think you can do this. I will say this is an operation, it's the way to go. We have to get it started. But the research line is also something very attractive that's going on in universities worldwide to make this a one-step process, to directly use the solar light to split the water. This sounds a little bit like magic, I might say. There are catalysts around, and our group is also researching along these lines, that can directly split water very softly. No electrolyzers needed, and these are huge machines. These are really big plants. And so the soft way to do artificial photosynthesis directly in the extreme only requests a single material that you can bring on panels, and then you can mount these panels ideally in your backyard, for example, with very low tech or everywhere in nature. And then you have a gas, would say, separation system to separate hydrogen from oxygen. And then you can harvest softly in that future line of research hydrogen wherever you want in a single step. I want to mention that we do catalysis along these lines, and also the photoelectrochemistry that's splitting the setup a little more is under very active research with us. And I think the most thrilling example for that soft splitting has been demonstrated by a Japanese group at the University of Tokyo to get real practical here by Professor Doman, has been published this summer, and they really did it. They made homemade catalysts, put it on glass sheets and covered in their backyard, literally 100 square meters with that soft and direct method. And they even had the panels freeze. And these were working, a very robust, simple technology. And maybe the fun part of this is they deliberately ignited their system. Many people are afraid of hydrogen, thinking about the fact that it could lead to explosions. There's a certain fear, but they really did it. They made the system explode at the end of half a year of tests, and the damage was, I would say, limited. They could recover 70% of the plant and large parts of the gas separator. So that's a technology that is more robust than we thought. And I think we should put in, to bring it to a point, research at all ends. We need research along these lines so that we don't depend on the power grid. That technology would be off grid. You could bring it to remote areas, to areas where you don't want to disturb nature with the grid, to developing countries and areas and remote villages, for example. That's a nice line of research. The more conventional line of research, but still necessary, is at the commercial electrolyzer side, where we need better membranes, better catalysts, longevity, higher efficiency. And also along these lines, I see that science will bring progress in the next 10 years. So with a molecular and atomistic understanding, we will hold the key to address these things. And in the end, we will have trucks driving across Switzerland's cars, and also be more independent of many imported energy sources. And most importantly, now is winter, we can store solar energy and hydrogen to cover our needs when it's cold and dark. I hope I raised your interest in that one, and I'm ready to answer questions.
Thank you very much, Greta. Of course, you have raised the interest, and we could listen to you much longer, but we also have some other technology that we want to project into the future. And again, I would keep the sequence and kindly ask now Alessandra Hall to go on with the rare earth recycling. So on the one hand, we have our hydrogen. On the other hand, we have the recycled rare earths, and this brings us more independence. Or how do you see it? 10 years, Alessandra?
Yeah, just to expand again, the rare earth is a one class of critical raw materials. But for example, the cobalt and the lithium in automotive batteries are also critical raw materials, and this is the scope of
course,
investigation we're doing. I see opportunities for many of critical raw materials, also for rare earths. The technologies are there. From international studies, also in Switzerland, there is research on different kinds of recycling technologies, and I think this will be crucial for every application, such as electronics or low carbon energy production that we are using. The largest potential at the moment for the future is definitely the electric mobility. And the reason for that is now because we have this extremely, I think, well-predicted steep supply, how this will develop in the next few years. So I think there is no doubt that electric mobility will take over pretty soon. And then there are really good case for recycling and circularity. They are more or less the most low-hanging fruit we have in the area, because the batteries of electric vehicles are so large. So you have a big mass and you have a high value of materials. So just the cobalt value of an average battery gives us strong incentives for recycling. And that's not the case for many of other critical raw materials, which are there in much, much lower amounts, so that it might not be economically viable. So if we don't manage to build up a good circular system for EV batteries, we will probably also not succeed with anything else. But I am quite confident that we will be there in 10 years. It's just really important to start with that now, so that when the first EVs come into their end of life, that we know what to do with them.
Thank you very much. Also extremely clear, and we will get a little bit then later on how to translate this future into real action, and what role the different bodies can play here and should play. And I would like immediately to hand over to Daniel Gigax now, who would bring in the view. Also, he offered many possibilities, but where do you see the lead, the key, the example that you would like to see pushed now, please?
Yeah, I will actually like to introduce one example. So in Switzerland, there are several 100,000 people who are limited in their mobility. And amongst them are many elderly people. They find it difficult to receive good medical care at home in a timely manner. So our motivation was to develop a practice to overcome this mobility barrier. And we have designed or redesigned an existing healthcare process around the customer or patient by linking Spitex, video doctor, and pharmacy services in a new way. This includes everything from a customer visit by a Spitex nurse who has on-site laboratory tests available, and to a video consultation with a doctor and the process for ordering and delivering medication by the pharmacy. So we at FHNW created prototypes for the mobile lab, the software library, and the digitized medical care. But maybe I can just go on and also answer the question, what are the biggest challenges actually in this process? Huh? And I have actually 4 or 5 processes, but I would only like maybe to measure the hottest, which is also often discussed now in this COVID pandemic. And the question is, are the tests accurate, precise, specific, and sensitive enough? And the answer is, of course, it would be nice if tests with the best specifications were available, but we have to put this requirement into the context of rapid availability of results, need, and costs. So test performance is not just a technical issue. It is also, or it also depends on confounding factors, such as inter-individual variability due to genetics, epigenetics, lifestyle, and other factors. And shall I go on with the question of 10 years? What is my
that's now the point, yeah? That is you end with that one, because that's exactly what we want to hear.
So an interesting example to learn from is the self-management of diabetes, I guess. Good diabetes control can prevent long-term complications or minimize their effects. And my wish is that in 10 years, it is self-evident to be responsible for one's health. So in the context of what we have discussed, this would include self-testing or easy access to complete decentralized healthcare services. So ultimately, this means that we allow self-management healthcare practices to become another cultural technique in the future.
Thank you very much. That is very important. I think what you didn't mention, but which also entails, if you talk in 10 years, you will transform the health system also. It is not only managing, with a specific example, diabetes, but what we said at the beginning, it's really a strengthening and transformation of the health system if it comes through. And I think that's the important contribution, where technology is directly, deeply interacting, as not as an addition, but interlinked with the health and social system of our society. And I think we should keep this in mind, and that's the thing that I see coming to us. If I would now go to Max-Erik back, we are back to the robots now in this world of this changed health and social system. Where are you when you look into 10 years, Max-Erik?
Yeah, so looking into 10 years is obviously a little bit difficult, but let's see what is happening at the moment and what are the drivers. So the drivers are actually that the robots are, as we said, too slow. So how can you make them faster without being unsafe? And the magic word here is, bear with me, please, impedance control. So impedance control actually means that you can vary the apparent stiffness of a robot. And that's actually what every human does. Yeah, so you can really touch something very lightly, you can pick up a feather, but you can also chop wood if you want. Yeah, and that's something which the robots cannot do. And so how can you do that now? There are three components to the whole thing. The first thing is actually you need very good kinematics. And for the kinematics, I mean something which has very low inertia at the tip and higher inertia here below. So like the humans, where you really have very low inertia at the fingertip. And most robots have normally the motors directly at the articulations. I think putting the motors back is something which is coming. And there's, for example, very good and promising research at the ETH in that respect. The next thing is, you need very good sensors. Also the same thing, look at your fingers are full of sensors, and there's a reason for that, because then actually if you touch something, you can completely change your program, and much of that is done subconsciously. So actually measuring the force of impact at real time is a big issue. And here, for example, we have an ETH startup, which is called Botta Systems, which does this exactly, and which offers very fast torque sensing, for example. But also Schunk is working on this, and there are many others who are doing this stuff. Then the next thing is you need some very good software. So you need software which does not put the control, for example, of position there, where you need micrometer technical drawings for something, but which is much more human. So looking at something and then grasping it and having kind of an about accurate information. And so this is a software which needs impedance control on one hand and artificial intelligence on the other hand, and also intention detection. So in terms of impedance control and artificial intelligence, we have, for example, a startup in the EPFL, which is called ICATech, which is very promising. We have also something which is called Micropsia Industries, which is more about handling cables and things with a history, which is also quite difficult. And then intention detection is still, I think, in the research. And it's still a long way off, but there is good research there, and also in intuitive programming. So how can you program a robot without being a PhD? That's something also where there is a lot of research being done, for example, in the Fachhochschule Biel.
Thank you very much. Also here, many tasks, but actually also promising lines. It's very interesting that you mentioned also the startups, not just as a small business, but as really as the drivers of bringing the development forward. I think that we got very clearly from your descriptions, and I think that looks very promising. Now, I would like to pass on to Anna Valente. And Anna, I think you would like maybe to add something to the field of automation and robots.
Absolutely.
Yes, but rather than continue with an assessment again with your two hats, that you actually also say, you know, how does Switzerland, in terms of supporting these developments that we hear now from the dear colleagues, do we do enough? Do we have the mechanisms to do it? I would like that you end with that one, and you're not only staying with your research, but you take this higher position and say, where is there some need that we do enough? Is there enough capacity to go on? You look in the chat, also the question of how we not.
We lost you, Marcel.
What happened? Would you like to, I don't know what happened, in not only Switzerland, but if you look at the question at the chat, it is really also the question how in the international level and how you bring the support also on the view of the Swiss Science Council into further on. Yeah,
I'll try to do my best to cover all these subjects. So first of all, from the perspective of the very specific subject, the theme I addressed in the outlook, for sure, you know, additive manufacturing till a few years ago was considered a disruptive technology, and right now is little by little becoming one of the technology of the portfolio for industrial stakeholders. So it's one of the, you know, of the technology chain available, and of course it's quite a promising solution. You can consider it with regard to a multiple variety of industrial value chain. To me, what matters the most at the moment is to consider this technology as a key instrument, for you know, the to enhance the life cycle of component in the next years. By that, what I mean is that we will have, you know, we do have big plans, you know, wind towers, power generation infrastructure, and in here, any stop of this plant is extremely, you know, it's a big burden from the economical perspective, from industrial perspective, from the services. And in here, additive manufacturing plays a key role for supporting repairing, for supporting refurbishing. So what concerns the brownfield rather than only the greenfield. And of course, it enables the development of complex parts with very enhanced mechanical behavior. Of course, which are the key barriers right now are primarily associated to the complexity of exploiting this technology, again, for reaching high quality parts. So we are talking about the gap of knowledge right now that you know, an early beginner should face in order to achieve very, very reliable components. Or at the same time, what matters the most if we look at a laser-based technology in general, is to enable people to, for instance, exploit very compact, very lightweight laser modules, for instance, to support in situ repairing. So to bring the modules around to make sure that this module can support manufacturing tasks in extremely harsh environment. If you think about outdoor repairing, so the, you know, laser technologies could really become instrumental to be brought in inspection and maintenance and repairing, and they could enable also a severe and extensive reduction of risks for the operators, being, again, compact and wireless and cableless and very portable. And this, of course, could be also a very interesting cornerstone when it gets to applying these technologies, integrating this technology on robotics, because now we are assisting at a number of mobile platforms for inspection and repairing. So we could have these technologies integrated on mobile platforms, running repairing tasks that could be prohibitive for people in terms of safety and health. So what I see for the future is, bringing together solution technologies, disciplines, in order to make sure that people could operate safely in the industrial value chain. And this, in my opinion, is a key cornerstone. It's very, very, very important. It should be a priority for every one of us when it gets to manufacturing. So to preserve the human capital, but at the same time to make sure people could operate safely and in health conditions. So the well-being of blue collars, for instance. Now, if we, changing the hat, so try to cope with your question when it gets to the role of the council. Now, as a Swiss Science Council, we trust excellence. And excellence means excellence in education and research. So these are the foundation to implement cutting-edge research. In Switzerland, for instance, we have actually quite a structure of funding pipeline to support strategic growth over the lifetime of a product, an approach, or a service. And we can access, for instance, a funding instrument enabling science-based research with SNF frameworks. We can access a variety of InnoSwiss funding instruments, especially for SMEs, when the maturity of a solution is a little bit higher. So we have on one hand the science-based, innovation that is very, very supporting. On the other hand, whatever is associated to a slightly higher TRL. So we are talking about a technology readiness level that ranges between 5 and 8. So we can enable the networking, strategic networking, strong bonding with several industrial stakeholders, with whom it's possible to establish fruitful collaborations. And InnoSwiss is a very key player with this regard. We have also funding schemes for bridging these gaps. So for instance, we are talking about the InnoSwiss SNF bridge program. Of course, in this case, we have slightly little room to operate because the program is a little bit smaller. Typically, the challenge, the critical area, at least in our opinion, pertains to the grays. So whatever is in the middle. So in the middle, we have technology research that ranges between 4 and 7. And here, our strategic agreement with the European Commission played in the past, and they're still playing a crucial role, as it enables a large-scale collaboration at European scale, at national scale, geographically, therefore, but also in terms of number of partners, types of stakeholders, as well as budget and time frames. And this is very important. Now, promoting for us, surfing and enhancing the technological research in Switzerland is, has always been a bottom-up approach. So this runs at quite fast rate of evolution. And in this sense, the funding institutions, especially at national level, in my opinion, in our opinion, should match flexibly these new topics, should react in a little bit more effective way by promoting new programs and enhancing, boosting heterogeneous research where transdisciplinary is actually the key to success in our opinion. So this is one aspect that would certainly constitute a key recipe for successful innovation and excellence of Switzerland at national scale, of course, but primarily also we are talking about European and international scales.
Thank you very much, Anna. This was a very nice addition, first of all, of the manufacturing and really the way of safety and keeping human capital and really move forward. Nice compliment. But now the discussion on, do we do enough? Can we do enough? I mean, we were focusing a little bit more on Switzerland. We would have to discuss the international level, particularly also the horizon level. And this is another thing to do. We cannot do all in this moment. I also know that Max-Erik must leave now, and I would like quickly jump, Max-Erik, before we make the final round. What is your last word here after this flashlights of technology? Where are challenges that we should more carefully look at? And then you must go, please.
Yeah, thank you very much. So yes, I would say the challenges are clear. We need better sensors, we need better intention detection, and so on and so forth. I would point to something else which I like actually about Switzerland, and that is that the education is quite good, but we have to know it. So we have very good support in the Fachhochschulen. I mentioned already Biel, there is ZHAW, there is Ost. They are doing an excellent course also in advanced robotics, which is held in Zurich, where the best professors in robotics at Fachhochschulniveau are there, and it's very high level, so it's not just some level. There's also the RSC courses in the ETH Zurich, and I think so we have very, very good substrate here for good programmers and for advancing also our science, which I'm really appreciative of. So that's my final word on this thing. And the good point for industry is actually that you then, if you, for example, are not sure if you can employ a robot or not, you can go to a Fachhochschule and have kind of a technology neutral partner who can show you around different robots. And then you can try them out for very low cost and can see, you know, is it really doing what I want to do or not? So I think that is a good point. I think in Ticino, there's also something, I saw something long years ago, and I think it has improved a lot. So I think there is a lot of stuff where we really have a good substrate and a good go-to places.
Thank you very much. I know you must go, but so the other ones for a few minutes still there. We have passed now our official time. Thank you very much, Max-Erik. And I would like,
thanks for having me.
Really just have the final round, but I start the final round now with asking again, Claudia Scherer was listening to all this, and you were very much involved. You are at the interface between the science and the whole industry. What are your short reflections, please? Short. We can only go on for a few minutes. Please, Claudia, what goes through your head when you listen to what is ahead of us? Please.
I just want to point out briefly our role as SRTV in the whole process. We kind of see ourselves as a translator. We really try to translate scientific findings for industry and to show it on the basis of a technology outlook. We try to show the relevance of the technologies for economy, but also mirror the competence. So how to see, okay, technology is really important for Swiss economy, but we still don't have the competence. It's kind of to show the gaps, to show where Switzerland is well positioned. We try to pinpoint challenges and opportunities specifically for Swiss enterprises, also based on the technologies we identify. And I think one contribution we really try to make is by translating, by showing the whole spectrum of technologies, we try to broaden the horizon of industry representatives, to look beyond the horizon, to see more, see left and right of their own technologies and applications.
Thank you very much. I think we could go then now more specifically in the role in the different technology you have seen. and or we were presented today. I would like now have the last sentence or two of the challenging thing, or what you take along and what you want to give along. If you can hear Claudia sitting at this interface, also Anna in the Swiss Science Council, what would you like to give along to them and to all of us, also the academies, where are challenges that we should address and so on? One or two sentences, please, that we can then happily close. Greta, you can start, please.
Okay, so in terms of future research, I would also point out that we can join forces all over Switzerland. We have excellent teams. We have NCCRs on the topic of catalysis. And we also have the strong movement towards circular economy that we heard today from Alessandra. So that is excellent. We can create synergisms here. And I think one creative idea towards hydrogen economy that what I'd like to pitch finally is, it's very attractive for investors when you get the hydrogen as a byproduct for free. So another line of research would be not to generate the oxygen that nobody really needs except for space stations, but to couple this reaction with something more useful like water treatment and cleaning or electrosynthesis. That's also pursued in some parts of Switzerland. We're gonna go for this also next year. So really that would attract investors a lot, getting rid of the oxygen making and getting hydrogen as a side product, basically for nothing, while driving another reaction that you really, really use. So in this regard, we could work together and also take care of recycling of the materials later on. I see these synergisms very strongly in the Swiss research landscape.
Thank you very much. And I think with your statement that you just focus on the research line, you also say the conditions given by the means to support this are given. We just have to do the research and get closer together. Very good to see. Alessandra.
Yes, thanks. I think for me, what I would like to have as a key takeaway from what we are doing is that we really, and we know it, but I still want to emphasize it, that we have to get away from the classic linear economic model and really think about resources and products in a different way. And this is not an easy task, as it's can not be done by one group in isolation. It requires collaboration all over the product and the research, but also the economic cycle. And to make the link also to the chat now, and it also requires collaboration with other countries. It's not something that can be done in isolation.
Absolutely, Alessandra. And I think we didn't have time enough to go beyond now the Swiss borders, because there is a lot could be said, and we would need another 2 Science at Noon to go through that one. Daniel, I mean, the transformer of the health system and social systems, what do you take along, and where are your demands in a way? How would you see it? As Lars said, now you are still mute. Please unmute.
I'm a little bit more skeptical than you. So from the experience we made on our consortium, and the actors of our consortiums actually have completely different interests at stake. So you see, customers may prefer to work together with the local general practitioner, but not with a video doctor. On the other hand, what I hear is that actually who will reimburse the costs? So this is a very, very important question which comes from SPITEX. Who actually pays them for all these activities we want to let them do in the future? So we are not only discussing technical issues, but also socio-economical issues. And these might be more important in the future to solve.
Exactly. And this is very good word to take along. It's the societal development and the technological development have to go hand in hand. And I think it's not just to work together, but actually really respect the point also that which came out of Anna's statement, what she would like to prefer, not just workforce, but that we are still together as active social tissue. And I think that's a very important message. And now you see, Anna, you are the bridge to you. You can have a final word, please, before we then close.
Thank you so much. Thank you so much, Marcel. For sure, I think that from the innovation perspective, we should be proud of the things we're doing. We are recognized worldwide, and our infrastructure, our frameworks are quite sustainable, I would say, if compared to other countries. In general, in here, the challenge and the complexity in any very cutting-edge field is to ensure the coherency, in my opinion, between the RTD goals, the things we would like to target, and the different funding schemes. So to make sure that the recipe is actually working, because we go from schemes covering different maturity stage or different subjects, and in here, making sure that everything smoothly works, it's very important. And of course, this means to tackle the topics from different perspectives, and this is quite key in terms of disciplines, but also in maturity stage. And in here, my wish would be to make sure that transdisciplinary research would take off. Definitely. And, for example, I would love to see roboticists with experience in manufacturing or physics of the optics dealing with process control. So this is something that we should little by little enhance, support, fund, and promote from the educational stage to the research and applied research till the development of a product and services which matter for the industrial stakeholders.
Thank you very much. Thank you very much. And this was a very good ending. I would like also to thank you all. I think we all take along that actually we have really, it's not just transdisciplinary as a concept, but we have seen that all the examples that were raised are interdisciplinary in nature, and the solution, how we bring it into the society, is a transdisciplinary one. At the end, it is totally irrelevant if the solution comes from this or the other discipline. It is only that we have a solution for our society. And I think this is what we take along and stimulates us in our own field, that this collaborative spirit, not just exchange and nice to meet you type of collaboration, but really the collaborative spirit to achieve something together is even more important when we deal on the one side with the technologies, as well as afterwards with the social tissue, where the thing must stay, further develop, and can be sustained for the benefit of the society. And I think that's very important. It's not only the interface between tech research and the industry, but it is and the society, I think, is very important. And I think this societal component we take along and we try to inject it in our research as well as in the research funding. And I think in this case, my last point is, in the development process, we should never forget that we do the appropriate validation in the different social, economic settings of our world, because very often we have good results, but we don't validate them enough before we promote them for the benefit of the people. So I would like to thank you really warmly for staying on. It was 15 minutes longer. But as you can see, with such a richness of inputs and on such a rich basis also of the report, we needed a little bit more. And I thank you very much. And I hope we stay in contact and we move on. So big thank you and have a good afternoon, and liaise with the people directly. If you could not answer, get all the answers from this panel. Thank you very much, and bye-bye now.
Thank you.
Thank you. Goodbye.
Bye-bye. Goodbye.
Thank you.
Thank you. Goodbye.